In this section, we are going to study the force. Force is a vector and causes motion of object. There are two types of the forces, long-range force and contact force. Gravity is an example of long-range force. And also, we have electric force. And magnetic force. Long-range force. And for the contact force, the object have to be in contact with some other object. Normal force, friction force, and tension force. If we place the object, exert a force on the object, so we call it this is normal force. Force from the ground. And the friction force and the tension force. In this case, the tension force comes from the string. Okay. At first, we'd like to study gravitational force. So this is the pictures of the Isaac Newton's looking at the moons holding apples. So he discovered the similarity between the motion of the apples and the motion of the moons. The apple actually fall to the ground. And then Isaac Newton found that actually the moon is also keep falling to the ground. So if there is no force acting between the Earth and the moon, we expect the moon is moving on the straight lines. But as an apple, the moon is falling to the ground, even though it cannot touch the ground. So the moon could make a circular motion around the Earth. This force is gravity. We could say the moon also falls to the Earth like an apple. When we would like to find a law from the observational data, we plot the data on the graph. Today I introduce an interesting log-log graph. This log-log graph uses a logarithmic scale on the both axes. So if you consider this is a v is 0.1, 1, and log 10s. Actually, log v is expressed negative 1, 0, and the 1s. This is actually graph for the log sum quantity to the log sum quantities. So this is a very interesting graph, I guess. Then what is the merit to use a log-log graph? Actually, if the two y and x has a relation of the power law, then if we plot the data of the log-log graph, if you take a log equation in the both sides, y equal ax to the b, take a log in the both sides, log y equal log ax to the b. Then this becomes log a plus log x to the b. So now it becomes log y equal log a plus b log x. So if you choose the vertical line is log y and the horizontal line is log x. So data on these straight lines. So by plotting the data on the log-log files, if the two data is related with a power law, we could discover such a law from the observational data. If you plot the data of the rotational velocity of the planet, the horizontal lines and the vertical line is a log r. So this is r. R becomes a 0.1, log r is a negative 1. This is 0 and this is 1. So for example, the Mercury, the radius is a 0.4 AU 0.1, 0.2, 0.3, 0.4. This is the position of the Mercury. And the velocity is 10 AU per years. So 10 you can find. So this is Mercury. And the Venus is 0.7. So this is 0.7. And the speed, rotation speed is 7. So this point is a Venus. The Earth is a 1 AU. So this point 1 AU. And it becomes 6.3. This is the position of the Earth. And Mars is a 1.5. And 5. This is the Mars. Jupiter, this is 5. And 2.7. This is Jupiter. And Saturn is 9.6 about 10. Then the rotation speed 2. This is Saturn's. Then data is on a straight line. So if you connect all the data, then you could draw the straight lines. Then finding the relation between the horizontal and the vertical axis. Then you could calculate. It becomes log V is a horizontal line. Is a slope looks like a -1/2 log R plus constant values. So from the data, if you look at this is changing the 1, the height might be changing 1/2. So the slope becomes nearly -1/2. Then if you choose a C prime is a log C, then this equation is expressed log C R to the -1/2. So from this equations, V is C R to the -1/2. So V, rotation velocity, is proportional to the R to the -1/2. So from the observational data, we could derive the relation between the rotational speed of planet and the distance of a planet from the sun. Okay, then we could derive the accelerations. So V, acceleration is given by the V square over R. So acceleration is given by the V square over R. And the V is proportional to the R to the -1/2. So acceleration is proportional to the R to the -1/2 squares over R. This is 1/R squares. So acceleration is proportional to the 1/R squares. And then if we combine Newton's second laws, ma equal F, we could derive F is proportional to 1/R squares. So gravitational force depends on the distance between the two objects. The gravitational force depends on some other variables. The next question. In the case of the motion of the Earth, Earth is rotating around the sun. And in the case of the Moon, Moon is rotating around the Earth. Then we need to include the effect of the difference of the central object. To include the difference of the central object, we need to modify the gravitational force. Is this way. Force is depend on the mass of the central object. So force is proportional to the m/r squares. Then finally we could reach the universal law of gravitation. universal law of gravitation said the magnitude of the force is expressed in this equation. F equal g is a gravitational constant, is a proportional constant. Then m sub 1 and m sub 2 is the masses of the two interacting objects, and r is the distance between the two objects. Then mass and weight. And the weight is actually the force. Weight of a body is a gravitational force that the Earth exerts on the bodies. Okay, so gravitational acceleration of the object on the Earth is expressed g is 9.8 meter per square second on the Earth. So weight is expressed W equal mg. This is the gravitational force. And the weight on the Earth, weight of a body is a gravitational force exerted on the bodies by the other bodies. So we consider that this Earth exerts a gravitational force on the object. So weight is exactly equal to the universal law of gravitation. And the weight also expressed mg. From these two equations, these should be equal. Then m is going to be cancelled out. Then g, gravitational acceleration, is equal to the g, mass of the Earth over radius of the Earth squares. So actually this Re is equal to the R sub E. Then actually the gravitation force depends on the distance between the two objects. Weight is also dependent on the distance between the two objects. If we place the object far away from the ground of the Earth, then weight can be calculated using the universal law of gravitation. This is the universal law of gravitation. This is equal to the weight. Weight of a body decreases inversely with the square of its distance from the Earth's center. Okay, this is the end of this session.